First thing is standard form, which we didn't have to worry about. Now we want to pick two equations to eliminate one variable. So looking at these three equations, let's call these equations, this one's equation 1, this one's equation 2, and this one's equation 3. What two equations do you want me to pick? Which ones can I pick so that I can make one of the variables drop out? The first two, what variable could we make drop out? X. I could do X or Z, but I saw something even, I think, a little bit easier. What about the last two? Notice I've got a positive 2Z and then I've got a negative 2Z. If I just add those together, what's going to happen? They'll cancel out. Now you can pick, there's no one way to do these. You can pick any two equations and then pick the other two. In fact, that's what we'll have to do. The first thing I noticed was that this is a positive 2 and this is a negative 2. If I add 2 and negative 2, what happens? You get 0 and they cancel out. So I want to pick these two first. So I'm going to pick, so equation 1 or 2 was x plus 2y plus 2z is equal to 9. 3x minus 3y minus 2z is equal to 1. And I want to add to eliminate the z. And what do you get when you add those up? 4x minus y is equal to 10. So notice that this is another equation. I'm going to make a note of that equation and call that equation 4. Okay, so now the next step. Pick another two equations to eliminate the same variable as before. So remember, we eliminated the z here. So now I can't pick those two again. So I can either pick these two or these two and eliminate the z. Which one do you think would be easier? The first one and this one or this one? Well, I know I have to pick the top one, right? Because I've already used those two, so I have to pick the top one, and then one of the other ones. Which one? I'm picking the. I would go for the third one, I think. So I'm looking at my top one, and I've got a 4z, and I need to eliminate that z. So I need to do what to eliminate 4? Subtract 4, right? So which one of these is negative already? The last one. So I'm thinking these two. Now you can choose this one. Okay, you can choose this one, but you have to multiply by negative 2. Let me show you how this works. So I'm going to choose equation 1 and equation 3. Yep. Uh-huh.
And it was like negative, and divided by negative 2x. Would it cancel out the 2x and the negative 2x?
Yes, it would. Yes, it would. And that's okay.
Are you allowed to cancel out 2 at the same time?
Yes, that could happen. That could happen. And that probably would have been a great choice, actually. It would have made this problem a lot easier. So, but let's just keep going the way we're going. And then maybe after the problem, I'll go back and look at that. So, choosing equation 1 and equation 3, I'm going to have 2x plus y plus 4z is equal to 12. Now, what do I want to multiply this equation by so that when I add to the 4z that they drop out? So, can I go ahead and write it out as 6x minus 6y minus 4z is equal to 2. Everyone see what I did? This was, I multiplied equation 3 by 2. Now add them up. This is 8x minus 5y is equal to 14. Oh, I should have done a different color. Let me write it out in a different color. This is equation 5. So I have taken 3 equations and I've created 2 more, but the 2 that I created only have 2 variables. Well, what does that look like? So let me just sort of put this together. So notice equation 4 and equation 5 only have the same 2 variables. In this case, x and y. So this is a system. And it is the system 4x minus y is equal to 10, and then 8x minus 5y is equal to 14. So now we've simplified the problem to a system with only 2 equations and 2 variables. And we started off today with about 5 examples of these. Okay, so we can do elimination or substitution here. Oh, I just realized that clock hasn't been set. I just looked at it and it said 6 o'clock, and I was like, that's not right. We start at 6, right? I'm going to keep you guys till 9:30 tonight. No, I'm just kidding. I'm not going to do that. But everyone see that this is just like the problems that we did before. So take a minute and try to solve this problem. I think substitution would be best. Solve with substitution is a suggestion. This one, because I can isolate that y. I would move the y over, and then I would subtract the 10, and then I could substitute y in. See if you can solve it.